Some forms of multivariate data are best visualized as a curve. This involves transforming the shape of the data to reveal its functional form. The visualization can then be further enhanced by grouping similar shapes together, and this is achieved by performing cluster analysis on the original multivariate structure. To be honest, trying to describe this process is much harder than just doing it inside JMP, so let's go straight to the software and see how it works. If you would like to follow the steps that I'm going to take, you can find the data within the sample index. Under multivariate analysis, we have Baltic data. These data represent samples from the Baltic Sea, so each row is a sample, and for each sample we measure 3 concentrations. These are concentrations of an impurity, and let me give the real names. Lignin sulfonate is a byproduct of the pulping industry. Humic acid occurs, I think, naturally as part of forestation. And optical whitener is a chemical that's added to washing powders to make your whites whiter than white. I believe they are independent of each other. Let's just confirm that. If I come to multivariate methods and do a correlation of these 3, then we can see either through the correlation matrix or through the scatterplot matrix that these 3 are uncorrelated with each other. Okay, now let's look at the other columns. I have 27 columns of intensity here. So all of these numbers you see are intensity measurements. So we have some type of spectral data. And V1 through to V27 are indicative of different frequencies that we have. So for each frequency, we have a measure of the intensity at each frequency for the different samples. Let's look at how those intensities are correlated with each other. If I come to the multivariate methods. So we're just presented with a massive correlation matrix. It's easier to visualize that as a color map. And boom. Okay, so everything is correlated with everything else. That's the nature of this type of data. Okay, so how do you make sense of such data where there's such strong correlations? Well, this particular type of data I refer to as, this isn't true for all multivariate data, but this type of data is functional in form. It's spectral data. We should be able to see a spectral waveform, but to do that we have to transform the data. Now I know the process I'm going to go through, and I know I'm going to have to do this twice. So to facilitate the repetition, I'm going to open a workflow object. This is new to version 17 of JMP. It works like a macro. I can start doing a recording, and everything I do now is going to get captured in that workflow. In fact, let me just help you see that workflow build as we take the steps. And what I want to do is take those intensities and stack them on top of each other. And let me explain why I'm doing that. I don't really think of myself as having 27 variables. I think of myself having 2 variables. I have intensity and I have frequency. And I would like to plot intensity versus frequency. And I can do that by stacking all of these columns on top of each other. So here are my stacked data. The data themselves are intensity, and the label represents a frequency. Now I think these are data have just been anonymized. More typically you'd have actual numbers in these here. So let me just recode this, and I'm going to remove the V so I can treat this as numerical data. To get rid of the V, I can do a string substitution and replace V with nothing. And now I can just replace that like so. So now my frequency are just numerical values, and let me reflect that in the data type and the modeling type. Okay. And you can see as I'm doing this, the workflow on the left hand side is capturing these different steps. And the final step now is just for me to create my graph. So these, let me just put in the observation here. So we have a different curve now for each of the 16 samples. I think it's more convenient probably to wrap those data and not show the data points. So I'm just going to put it like so. Now at this point I can close this. Well, let me just make some observations. The reason for changing the aspect ratio like this is to help emphasize the shape. Now I think I'm losing the shape a little bit by using the smoothing curve. So let me just come back, and instead of using the smoothing curve, I'm going to connect the actual data points. So that gives a bit more nuance to the shape of these profiles. And if you look at them, if you look at these two profiles, for example, they have the same shape. If you look at this one and let's say this one, they have pretty much the same shape, or certainly this one and this one has got the same shape, and it's different to this shape. So if I think in terms of, now this is probably not the right sort of language, but if you think in terms of the steepness of this slope, this is very steep, and then this is less steep, and this is getting quite flat. So we have at least 3 distinct shapes in here. And I want to I can't think about 16 different shapes. My brain can't cope with that, but I can probably deal with 3 or 4 shapes. So I'm going to use cluster analysis to cluster these profiles into a cluster such that every entry within every element within the cluster is going to have the same shape. So what I want to do that, I have to go back to the multivariate data, and that's why I created the workflow. So what I can do is close the graph builder and stop recording. And I love this button. It's just a rewind button. You press the rewind and you end up at square one. And what I can do now is take these intensity data, and what I want to do with them is to cluster them into, let's say, 4 clusters, I think. So if I put number 4 here. Now I don't need to dwell on this platform. I just want to come into here and save those clusters. And if I come back to the data table now, I've got a cluster number for each of the samples. I also have a distance, which I don't need. I'll delete that. Now I can come to my workflow and I can just rerun that workflow. And it's going to rerun the analysis I did, and I'm back to this graph. But now when I open up the control panel, I have visibility to the cluster number, and I can color these profiles by the cluster number. And hopefully this is going to reflect what I was seeing myself. So these two had the similar profile, and then I said actually that these two had the similar profile, but no, it's actually kind of given this one and this one. That's fine. And then you see these are very similar to each other. So, but we do have this notion of this. This is, again, the language may not be correct, but this is very steep. And for the blue, it's less steep. And for magenta, it's even less steep. And then we've got some miscellaneous shapes with the red cluster. So let's now see if we can make sense of these 4 clusters in relation to these concentrations. So let me come to the data table and do a distribution of these 3 impurities and bring them up here. And now let's just look at these profiles. I'm going to select the green ones first of all. So those are the green. And you can see the green correspond to high values of a lignin sulfonate. They go across the entire range of humic acid, and they are the upper half of the optical whitener. And this profile corresponds to that steepest slope. The next steepest would be blue. That's this cluster here. And you can see, so with the green, we were at the high levels of lignin sulfonate. Once we go to blue, which is getting flatter, then we've come down slightly. So we're now in a range from about 1.5 to about 3. And if we go to the next level of flatness, which is the magenta, we're coming down yet again to about 1. And then finally, we've got these miscellaneous ones, red, and that's down towards 0. So we can get a sense that those clusters are given a correlation with the concentration of lignin sulfonate, and the shape is directly sort of correlated with that degree of concentration. That's as far as I can do, or at least as far as I want to do in this video. The key thing I wanted to show was this idea of clustering the data. You have to transform between the multivariate view and the functional view, and you have to do the cluster analysis in the multivariate view in order to visualize the clusters in the functional view. But I think it's a very powerful technique. You can't always guarantee that these clusters are going to give you a meaning, but it's much easier to think about 3 or 4 clusters and 3 or 4 shapes rather than 16 different shapes for all the different samples. And we're starting to get some good insights here. The next step would be to go beyond exploratory data analysis and do statistical modeling. And in fact, the appropriate analysis would be to use partial least squares analysis, or if you have JMP Pro, you could use the Functional Data Explorer platform to look at the relationships between these profiles and the concentrations that we have. If you found this video helpful, please give it a like and think about subscribing so you can easily find future videos. All the best. Bye for now.